Hello. Good evening, everyone.
Hello.
Yeah.
We'll wait for a minute to see if someone joins in, and then we can start. So, did anybody try the lab assignment that was given last week?
Yes, Lavanya.
Okay, super. Do you have any queries?
No, actually, I have tried the L3, L4, L7 and with the namespaces, but
Okay.
yeah, those are clear, but I didn't get a chance to try the ETCD backup.
That's fine. It's ETCD backup is not a big thing. So, if you tried the Cilium network policy, that is great. So, I want everyone to make use of this lab assignments because you will really understand what's happening if you try it yourself. And we can't cover all the concepts. I can give you the topics. So maybe if you could explore it, you know it better. So you have your own understanding of it. So you will go through some material. So I want everyone to make use of this lab assignment and do the lab and then come up with some questions. So I was expecting you guys to post some queries in the channel if you have any doubt, but I did not notice any queries. So, but I want everyone to be active because you are also spending a lot of efforts here, and I'm also doing efforts from my side. So it's better that we use our time. Yeah.
Yeah, one small note. So, do we need to allow the ingress rule for core DNS every time, or can we skip that? Like, because when I tried giving the deny policy, and after that, when I deleted that policy, and when I tried, I'm able to get do the HTTP with the IP address.
Mm-hmm.
Again, with the host name, I'm unable to get it because of the code DNS deny policy is getting applied even after deleting.
Okay. So what you can do? So did you apply it through namespace or is it at cluster level?
Namespace.
Okay. So if you want to override all the namespace things, what you can do, there is another thing called Cilium cluster network policy. So the syntax and everything will be same. The scope is at the cluster level. Okay. So instead of namespace level, what you can do, you can allow all traffic to KubeDNS. And for example, if your company is having some DNS to be allowed, so you can configure it in Cilium cluster network policy.
Okay.
So that you don't have to worry about if a policy is deleted or if it's created. So if it's it's there and then it's stored somewhere. So maybe this would help us to address the issue. Okay. And so in production case also, I want to give a use case for this. So we don't allow a lot of Cilium cluster-wide network policy. Then there is no point of having a namespace restriction. So certain things needed at the namespace level. For example, if an application is trying to reach some gateway service or they have their own front-end IPs or any client network domains. So in that case, specific things are allowed at the namespace level. So this type of segregation will be done there. So it's better you decide on which policy to apply. So for example, KubeDNS, you see that it's blocking and you have to allow every time, right, for a new namespace or new workloads. So whenever the pod is deleted also, so if you are doing it at the pod level, then your application will not work. So then generally what you have to do, you have to create at the namespace level, allow it for the deployment to contact the KubeDNS server or do it at the cluster level. So that's one thing you can do. So in L3, you should have tried some IP address ranges to allow. Did you notice that traffic is denied in the Cilium Hubble UI?
Yeah, correct.
Okay.
It used to.
Yes, that was the intention of the entire lab. Yeah, so I want everyone to try whenever you have time. So I don't think it will take long time. So hardly it should take 30 to 1 hour, 30 minutes to 1 hour. So yeah, try that and then come up with some questions. So I'm happy to answer any questions if you have. Yeah, you can post your queries in the WhatsApp as well. So I will try to respond when I get time. Okay. So which is good. So in L7, you would have seen path-based routing. So that is that's giving advanced level of policy in L7 based routing. So Cilium, I think with the network policy, it covers a major part of it. So another one is the CNI part that we have already seen, and Hubble is one part. So maybe we could do some Q&A for the Cilium. So I want everyone to answer. Just try to recall what we have done in the last class, or maybe you can make a note of these questions and then go and search if you don't know as well. Yeah. So what is the difference between the Kubernetes policy and Cilium network policy or Calico network policy? What's the difference?
Kubernetes network policy gets applied for the pod level, whereas the Cilium network policy for the endpoints.
Okay. So how we can say basically this Kubernetes network policy is at L3 and L4. L3 means IP, L4 means port. Okay. So these two are the layers the Kubernetes network policy covers. But Cilium or Calico network policy, it targets L3, L4, L7. Okay. So you can remember that it's based on the layers. So that's how you can answer for such questions. And in Cilium, you might have seen HTTP traffic, DNS traffic, gRPC connection, FQDN, everything is supported. It's not necessarily, it has to be only an HTTP or, the basic UDP level of traffic. So it supports FQDN as well. And specifically, it also supports some Kafka related traffic policies as well. And so what is identity-based security in Cilium? Any idea? I think we have discussed this in the last class. So I want someone else to answer. Maybe Priyanshu? Sorry for calling out your name. If possible, you can respond. Okay. Anyone else?
Shall I?
Yes.
So yeah, source identity. Usually in IP tables, the network goes like line by line, like each like each layer it will see the matching and it will check. Whereas in the Cilium, it will do the hash map thing where it will provide an identity number with a matching label and selector, and that's how it is without latency we can send the traffic using Cilium.
Exactly. So basically, you can define like for IP tables, it's basically based on the service IP. The service IP is the one that is mapping all the pod IPs. So these are whenever there is a pod that is getting deleted, this service IP will update it. So this is not parallelism. So it does it in a sequential way. So that one you have to remember. That's why it will create a lag. But when it will create a lag, is it for a 10 node cluster? Do you think that this lag will be visible? Hello. Yeah. Am I audible? Yeah. For a 10 node cluster, do you think this IP address lag will be visible? Like network lag will be seen?
Yeah, because it has to go hop by hop.
Okay. But ideally, a small cluster you will not see that difference, Pulika.
Okay.
So this will happen when you have 50 or 100 plus of nodes, and then lot of communication between the microservices. So there are a lot of dependency. So if you visualize it in the dependency graph, it will be lot of connections. So in that case, you will see an error. You will see the lag. So not for the small or medium-sized cluster. Small in the sense, I would say So 10 to 20, it's a small cluster, I would say. A medium cluster would be maybe 50 to 60 or 50 nodes. Large cluster is, you can consider like more than 70 or hundreds or thousands. And yeah, so enterprise scale means it goes beyond, so endless, right? So that's how it is. So that's for the IP table, but just I want to reiterate what Poluka said. Cilium assigns security identities to the workloads. So every deployment, so you, for example, for every deployment, you have a pods, and then for every service, it has their own IPs. IP table is based on these IPs. But when it comes to Cilium, each and every deployment will have an identity, like a 5-digit number that we have seen last time. So that identity is assigned to the deployments. So that's how these deployments are identified. So how this is assigned? So each and every deployment will have a label. So for that label, identity will be assigned. So connectivity will be from source identity to destination identity, not from source pod to destination pod, nor the service. It's based on these identities. So which makes getting rid of IP address. Yeah. So that's how it is used. So that is a greater advantage, and it's widely adopted across all, even now in the enterprise platform and managed clusters. Okay. Yeah. So moving on to the next question. So what is that L7 policy enforcement? So what is basically L7? Any guess?
Application layer.
Application layer. But what protocols?
Through HTTP protocol, we can use different methods like get method.
Yes. HTTP, so basically path-based and gRPC methods, DNS, FQDNs, everything will be, and so whatever in the application layer traffic, it will be covered. So get calls, post calls, yeah, all the CRUD operation you can filter. Okay. Okay. So with that, let's move on to the week 3 session. So today we are going to look at the autoscaling in Kubernetes. So we will see what's HPA, horizontal pod autoscaling, VPA, vertical pod autoscaling, KEDA, event-driven autoscaling. Cube event-driven autoscaling. Node scaling is how we scale nodes using cluster autoscaler. So there are a lot of other types of scaling available, like spot scaling is also there, and cached AI is there. So these are different types of external scaling mechanism that are there. But for now, we will see these for our maybe for the lab session. We'll try how much we can cover with the kind cluster. So yeah, with that, I think we did a recap of Cilium, and we might have been familiar by now for the etcd backup and restore, and K8's cluster components we have revisited. So this is done for the last 3 sessions. So do we have any audience who joined for the first session today?
Hi Lavanya, I have joined today.
Okay.
I went to the first lecture. I'm setting up lab.
Okay. So do go through the week 2.
Yeah.
And then you will understand what we are talking about the Cilium.
Sure.
We have covered a lot in the week 2 for the Cilium, so which is a major concept in Kubernetes, which is a container networking interface. So which is the base of your Kubernetes cluster. So it is the service networking that's offered by external tools like Cilium and Calico. I want you to go through the session so that you will follow. So there is no continuation. So each and every class is independent, but I don't want anybody to miss out any tools, because these are enterprise grade tools which are widely used. So if you plan to go for an interview, definitely they will ask all these areas. Okay.
Yeah, I'll cover those.
Yes, please. Thank you. Yeah. So without any further delay, let's get started. So the agenda for today is, first we will see what is scaling first, what's the horizontal pod autoscaler, vertical pod autoscaler. Possibly we will cover demo for any of this, either HPA or VPA, but I have the demo for VPA. So sorry, lab for VPA. You can try it yourself or you can explore it further. Like in the lab assignment, I will try to give whichever is not covered today. And we will see what's cluster autoscaler, what's the difference between this horizontal pod autoscaler and cluster autoscaler. And then we will see a tool called KEDA, event-driven autoscaling. So, yeah, we'll see how we can utilize this KEDA. And maybe in the production case, this KEDA is widely used. So whenever there is an event-based traffic that comes in, for example, if there are a lot of load that comes in, basically if they receive any event there, so your pod has to scale. So that's how this the scaling differs, but that we will see in the upcoming slides. So when to choose what, so that also we will see, so that we understand all these differences and then what to choose in which scenario. Okay. So that's what the agenda is. Okay. I'm sorry that I didn't share my screen. Is my screen visible?
Yes.
Okay, my slides are visible, right? It's in the slide page. Okay. So thanks for pointing out that. I might miss that sometimes. I appreciate if someone raises that. So this is what our agenda is. And then, so before moving into auto scaling, we have to understand what is Kubernetes service. So, but by now, every one of us knows what is pod. So can someone answer me what is pod? Just a quick recap for the new joiner, Abhishek.
It's a basic lowest unit of Kubernetes. It can hold containers within them.
Okay. So I think I appreciate you responding for that. So do you create a pod when it comes to creating a new microservice or onboarding a new service? Do you create it as a pod? Do you think that will work out? No, right?
Like basically, we deploy as deployments. It creates replica sets and pods with below them.
Right. Because this is ephemeral. Pods are ephemeral in nature. So it can be deleted anytime. And nodes are also ephemeral in nature. It can also be deleted at any time. So we should, for the stateless applications, we should not always think of the pod state. So it can be deleted at any time. So that's why you will see any pod identifier in a random numbers. So basically deployment scales creates the replica set and replica set creates the pod. Okay. So this is one line of story. The other line of story is these pods will have its IP address. But how does this pod communicates with other pod? I have an application 1 and I also have an application 2. So these two pods has to communicate. So how it will communicate? It will communicate through service. So it will not communicate through pod. So there no pod to pod communication will happen directly. It happens through the service. So that's your Kubernetes service.
Yeah.
Any questions up to now?
Good learn.
Yeah. Thank you. So in Kubernetes, so this service, you can just go and read about it. You will get it better. So you don't need much explanation, but I would still clear it. So we are not going to create a sample of all these services. So we are going to deep dive into what we can accomplish with each type of service. And then we will see the real use case, when to use what. Okay. So this service anybody can create. So we have created deployments, Nginx deployments, and we have exposed the deployment. So that means it creates a deployment and then we have exposed it as a cluster IP service. Okay. So we are not going to create one sample for each of this and spend time here. So we will eventually pick it up when it comes in. But yeah. So there are 3 types of service. Basically, by native Kubernetes offers. The first type is the cluster IP. So whenever you create any service, by default, it comes and come with an IP address, which is cluster IP address. So this IP comes from where? Any guess? The service IP.
CNI.
Any other guess?
Proxy.
So this is how we create kind cluster. My screen is visible, right?
Yep.
Okay. Yeah. So this is how we create the kind cluster. So there in the networking, we configure pod IP and service IP. So though so we might use different CNIs, but still we have to configure what is your service sider and pod sider. So all your pods will be of this range, and all your services will be of this range. So this is where it has been configured. Okay. So yeah. So you have to configure these two without having a conflict. It's completely a different range. So, and also there should not be any conflict whenever two clusters are talking. Even these two clusters should not have any conflict, because if there is an IP conflict, then it will have a problem in reaching the other service. So that's why if you decide on creating a cluster architectural design, then first thing what they will do, they will sit down and then segregate the IP. For production, what would be the IP? For non-prod, what would be the IP? Because we have to consider all the migration scenarios as well. And then based on that, so there can be a chance that each cluster has to communicate. So these IPs should be, it should not be identical. It has to be different ranges. And it does not need to be of a bigger range. So you have to design like how much nodes you want to scale and how much pods you want to assign for each node. So the count is based on that. So the CIDR notation is based on that. So that much you can scale. For example, you just give a smaller range, okay, /24, and then you expect your cluster has to be scaled to 1000 or 5000 by configuring 250 IP address for the pod without Cilium. Without Cilium means what it will happen? So basically all your pods will consume from the subnet that you are configuring, and each and every node will take 250. If you're not defining less like max pods with a different number, by default it takes 250. So each node can create pods up to 250. But do you think that in production we will create 250 pods per node? No, right? Because we will assign each and every pod will have the CPU and the memory assigned to it. So it is must that you have to assign CPU and memory. Let me show you. So each and every pod will have a CPU and a memory assigned to it. So you cannot consume all the entire capacity, and then so these are the configurations. So this cluster IP is the default one. So now you know from where these IPs are assigned. So it's coming from the service CIDR, and then you are configuring this while you are creating the cluster. So these are the things that you need to consider when creating a cluster. So it's one-time configuration. You cannot just like that change it. So yeah, so you need to be careful while designing it. And then the second type of service is node port. So basically,
Sorry to interrupt, Lavanya. I just have a question that what if the mention memory of a pod, if it reach or it exceeds in limit? If you limit, suppose 256 MB memory to a pod, and if it exceed that, then what happens?
Okay, good question. So basically what it will do, for the first time pod assignment. So I'm creating the Nginx pod right now. And then first thing what it has to do, it has to go for scheduling. Your scheduler has to find the right place to schedule this pod onto the node, right? Right, Chetan? So based on what number it will check for which node it has to schedule. So it's based on the request. So it's not based on the limit, it's based on the request. So first thing that it checks is 10 millicore CPU if that node has it. So that is an eligible node. And then for the memory also 32 MI memory, it will check and then it will go on schedule wherever the node is available. So then the scheduler job is done. So this is for the first time pod creation. Now you are giving load for the application. Okay, so you are giving load. For example, you're giving a CPU load. Okay, CPU intensive operation that if you are performing, then what it will happen? It will reach up to 100 millicore, right? So it will go up to 100 millicore, and then beyond that it cannot go. CPU is a hard limit. Okay.
Okay.
So it will throttle. So you will see errors on the pod. It will not go beyond the limit that is set. So this is called hard limit. Okay. But when it comes to memory, from 32 millicore, 32 MB, then it will go and reach until 128 MB. So this is not hard limit. This is soft limit. Okay. Then what will happen? OOM kill will come out of memory. So it will go beyond this. For example, I have a node. So my node is not 100% utilized. My node is 90% utilized. Okay. So my node is 90. So I will take the question later. I will clear Chetan's query. So my node is 90% utilized and I still have some space, like still have some memory left on my node. So what it will happen, will go and continue using that 10%, and finally if it reaches that and say like entire capacity, and then it will give OOM kill. Okay, so this is called soft limit. I think it's good that you raised this query, Chetan. So yeah, clear, Chetan?
Yes. Now it is clear. So when CPU exceeds, it's CPU throttle, and when memory exceeds, pod will be killed. OOM killed.
OOM killed. So randomly you will receive errors in your application.
Sure. Okay.
So if you refresh, it will work. If that new pod will come up and then it will survive the traffic. Then again it goes and reaches that level. So what you can do, you can basically check why your application is behaving like that. Maybe they don't have a cache, or this is where your application team comes into picture. They will have to check this pattern. So, but what you have to give them the details, like this is how your scaling pattern is. So you are getting a lot of OOM kills. So every hour you are getting OOM kills. You have to publish this data to them so that they have to fix their application with a new release. Okay, but there is another option, like just you can go and increase the limit. But how long you can do that? It's not the right choice, right? So not every application team can do that. So maybe up to, for a temporary fix, you can do it, but for as a permanent fix, the application team has to work on this and come up with a solution. So this is, this is how it will be done in the production. Okay. So maybe we can just see through this deployment. So each and every deployment will have a similar template. So maybe few fields will be extra that we will pick up when we get to that point. Okay. So what I am interested is, this is the API for deployment, but for pods it will be just V1. So these are core APIs, but these are deployment or extended APIs, I would say. So basically you will see an API version, different API version. For networking, it was networking.io. For storage, it is storage.kubernetes.io. So this will change. Okay. for each and every service, and for each and every YAML that's deployed in Kubernetes, it will have 4 fields by default, which is API, version, kind, metadata, spec. All these 4 fields. But in case of config map, data field will be there, because config map and secret are for storing the configuration details. Secret is for storing the sensitive details. Config map is storing for your configuration details, which is not sensitive, like your host name is not sensitive, but your database password is sensitive. Okay, so these are primary use case for config map and your secret. Yeah, so that's one thing. And each and every deployment will have a template. So template means this is the template. So whatever pods that are having this template, it will be grouped under this deployment. And then each and every deployment can be labeled. So it is not necessary that it has to have a mandate label, but it is always good to call by a name, that is label. Okay. And then under template, you will have a spec field. So this spec field is for your deployment. This spec field is for your pod template. Okay. So you don't get confused. So this is how it will be. So this is for the deployment itself. This is for the pod. And pod, each and every pod should have containers, one or more. Okay. So we are going to see only, so this is the normal container. I will discuss about sidecar container when we go into the Istio session. And there is another thing called as init container, that also we will discuss, yeah, when we see the such examples. But for now, this is your application container, and this is your name of your application, and this is the image that is being used by the container. And then this is public image, but I can access public image. But if your cluster is secured, if it's not allowed, then what you have to do, you have to configure. So you have to use image pull secret. So basically, it's just having an authentication to your registry, container registry. So what are common container registry? Any idea?
Docker Hub
Docker Hub, QA,
ECS,
is yeah.
GitLab,
ECS, Elastic Container, ECR, sir.
ACR, GHCR, yeah. So lot of container registries are there. Some are public, some are private. So you'll have to have authentication mechanism to it. So if it is a private, first thing is image pull backup will come. Okay. So you'll have to first check whether it is, it can pull that image. If it's a public repository, you have to configure a secret to authentication for that Docker registry using the Docker URL and authentication mechanism. All these need to be passed. Okay. The resource column, we have just seen it. And since we are going to discuss about scaling, end-to-end scaling today, it is mandatory that you will have to understand this block completely. So that's why I wanted to go through the entire deployment block. So you understand what are the fields that will be there for the deployment. And this is mainly used in terms of scaling. So based on this only your scaling will happen. Okay. So by the name. So what is probe? Any idea? What is
Checking the service.
Checking the service status. So
We can say health check.
Exactly. Health check. So basically you have created your application, but you need to find a mechanism to check whether your application is healthy or not within your container, right? To do that, you'll have to configure few probes, but these endpoints should be available in your application, in your microservice, in your container. So these endpoints should be exposed. Then only you can reach. Okay. So /health or API, or maybe sometimes if they don't mention, I just put Swagger just to check health. Okay. But so these will be decided by the application team when they configure it. But yeah, so this is your application port where your application is running. And then initial delay second. So for example, if your application is very huge, it is consuming 8 core of CPU, entire node capacity, if it consumes, it might have a delay. to get ready, right? So by the time you don't want your service to send traffic to that pod. So how it stops the traffic? It's based on this probes. Okay. If it is failing, first thing that service will do is it will take out this IP address, like pod IP address, from its entry. So this pod will not be sent traffic. So that is the reason why we need to have this probe for each and every deployment. So now you know the impact. What if a probe is missing, readiness probe, specifically readiness probe is missing, then your application is considered as not ready. Okay, if this fails, for example, if all of your pod is failing with the readiness probe, then your application will be down and none of the traffic will be sent to your application. But at least you know that it is down. How you will know that? It's based on this probe. Yes, Ganesh.
So quick question, sorry, I'm dealing with this issue on daily basis. So OM killed error, right? So what happens is we have set the JVM heap utilization set up to 40 to 80%, okay? Min max heap, 40 utilization of, let's say, it's a memory intensive. And then the criteria that we have kept is max heap 40 and minimum is 40 and max is 80. And what happens is we always get this liveliness readiness probe failure, and we check further on the kernel logs on the parts, then our parts are the nodes, then we get to know that the OM is killed error with exit code 137. Okay. And JVM utilization is not at the max. Okay, that is also there. So, but the overall pod memory got maxed out because we don't know what. Initially, we didn't know what's the root cause. But what do you think? Like where exactly this could be a problem? What they told me is, I mean, the infra team, what they informed me is after some analysis, the overall pod memory is not able to have a sufficient memory for the non-heap threads and stack, because the pod is already consuming 80% of the memory because of the heap utilization setup, which I agree, but sometimes these calculations might go wrong, right? So what would be the best practice, because this OM killed error is there in production as well? So any suggestions or best practices that you could follow?
So this is the ideal case, not only for your environment, it is happening the worldwide. So this is the problem that every application, when there is a load specifically for Java based application, so your JVM heap is not equal to total memory used by the pod. So JVM heap is just one part of the memory used by your Java process. So there can be multiple things that's running behind the JVM heap that's causing your pod to use its maximum memory. Okay, maybe I don't know if the garbage collection happens by proper.
No, JVM looks all good. JVM usage. See, I'm working as an SRE as well there. So JVM usage, everything looks fine. There are GCs are happening as expected. JVM utilization is under 40-50%. Less than I would say 50 or 60. But how come the max heap is already consuming 80? I mean, like allocating 80% of the memory, though the heap utilization is less than 60.
So, what is your request that is configured?
Okay, I don't remember exactly the number.
You'll have to check the request, and then. So this is majorly like you just play around it by changing the values of your JVM and then identify what would be your saturation point. And then basically this is how it will be dealt, like changing the request and limits. And then if your application at the start, it requires more resources, then configure the higher request there. So that is one thing. And also the JVM min max, it has to be considered, like I think there should be a ratio between the pod and the JVM heap that is being configured. So you'll have to play around with these values really in the production to see how it's performing, and also trace the calls. So what calls are being made during that time, so which is causing this application to go down. So you have to have a tracing tool to trace what and all calls it is made during that time. So if some call is taking longer time, then it causes load to the pod. So it is not necessary that only JVM that can cause your application down. That's not the case. You'll have to trace each and every calls. For example, if it connects to few APIs, then it, just
Sorry
have
to interrupt. Here the issue is the allocation, right? What I got to see is the allocation that we are giving 40 min and 80 max is actually JVM is actually consuming 80% of the container. I mean, for the container memory. So ideally, whoever has given that min max 40-80% might have not explored much or played around with the numbers. Going directly with that 40-80% allocation for the JVM, left with the 20% for the remaining operations to be done on the pod memory.
That's low. I think you should at least consider 60 to 70% for the heap, rest of them for the pod at least. So maybe this ratio can be revisited, but it's on case-to-case basis. It's not, there is no hard answer for this.
So for the C group error, then on the kernel level, when you check that, sorry for taking time, but one last question. This C group memory error also appearing very often.
Okay. Have you also done some stress tests to see when these errors are coming?
No, this is happening directly in production. So.
So C group out of memory is basically killing the process. Okay, so that comes in when there is a OOM killed. So this can correlate with each other. So not necessarily these both are different. So if OOM kills also, your process will get killed out of memory. So C group out of memory. So both are dependent. So moving on to the probe again. So readiness probe. So basically to send traffic to your application, this readiness probe is the important point. So if this fails, your application will not be sent traffic. So the initial delay is, if your application is quite intensive, you can introduce some delay to make this application start by the time. So for example, if I give 15 minutes delay for a Redis application, for Redis based instances or some database related pods, then I think it would wait for 15 seconds before the pod to go in ready state. So you might have seen like running will be taking some time. So few seconds it will be taking. So you will not see running immediately. It will container creating, initializing. So all these status will be coming back one by one. Then finally it goes to running state. So that type of delay is based on the initial delay seconds that is configured. And so period second is every 3 seconds, this readiness probe will be checked. So every 3 seconds it will check. If it is failing on that particular time, then there is another thing called retry time. So it will try for 3 times, and then if it fails, then we also mentioned that timeout seconds. So if it takes long time, then we'll have to give a timeout. Then it will again go and check in the next periodic second. And if there is based on the number of retry configuration that we have done for that application, like then it will go on failed state. Like application will not be in running state. It will go to 0. It will not give you 1 bar 1 or 2 bar 1 in your application status. So it will go in not running state. So this is the important document that you will have to use it on the day-to-day basis. It has all the configurations. So I was talking about just 2 or 3 parameters. So we have multiple parameters like read, write, timeouts, everything. So just have a look at this configuration, and then one lab assignment you can do is just try this and then try to introduce some failure and see what happens. And also increase the initial delay and see how long it is making your application to slow down on the startup. So these and all you can verify it. So when you have time, just to go through this document and play with these probes. Okay. Yep. So we were seeing about the readiness. So can someone summarize what will happen if the readiness probe is missing? Yeah, can someone answer? If it is missing on your deployment, what will happen?
Kubernetes will think the application is not ready and it will not transfer the traffic.
So if we don't set
Probably
readiness
it will
probe at
not
all,
show the health status.
okay. So probe is the point to check
What
your application is ready or not, right? Then if your probe is missing, then we don't mention that any criteria that he's alive, right? He's alive there, right? So then what it will happen? Your pod will be up, okay, but your underlying application is down. So it will give a impression that your pod is up, but actually your application is down. So you will, first thing what you will do, you will go and check kubectl get pods and you will see running. So then you will tell the application team, hey, I have my application running. Okay. So then there is no problem at your end, right? But what application team will think? Application is down. So where is the hidden problem? Because you have not configured the readiness probe. So there is nowhere it can check whether the application is ready or not. Okay, it's still dead, but it is acting alive. Okay, that's the readiness probe. Did it clear, Vaibhav? What you said is the other way. That's not the case. Okay.
Yes.
If your probe is missing, your application will be running. Yeah. But I want to, I'm raising this question so that you think of the logic and then why it is there. Yes, Vaibhav, tell me.
Correct. So now, Lavinya, I just have a question. So the path is going to health, right? So does the readiness probe first go to the path in health and check what is going on? Like, how does it work?
Yes. So basically, it does check HTTP get probe. This is a HTTP get probe example. So there are different types of probe. TCP probes are there. DNS probes are there. So this is an example of HTTP get probe where you are checking the path and on that port. If this is running on that application, then it will consider this is working. So consider like 200. Okay.
Got it.
So if this is not there, completely you just removed it, then it's not the right way to deploy an application itself. So these are the mandatory parameters every application should have. So without readiness probe, and sometimes they will set the readiness probe to /health, but they have the application. So that's not the right way to check their application. For example, they have the API running in different, like /API or somewhere else, but they're checking in health, but it always sends you 200. But then it's no point, like it's a fake probe. So what we'll do first, if an application team comes into us, first thing that if they come to us, what we will say, hey, you have to configure the probe. You have to configure the readiness probe and liveliness probe. Then what they will do, they will just go back and they don't create a new health point for us. What they will do, they will give a dummy health point, which will always give you 200. Okay. So which will make your application always running. So that fake endpoint also they can give. So it's all based on the application team. So but what we can do is we can advocate them that these are the mandatory thing that has to be configured. Okay. So if they don't mention the right API, it's their problem. But from our side, we are safe that the application is running. So based on the probe. Okay. So that's for the readiness probe. What's the liveliness probe? So one of the main advantage of container orchestration when it comes to Kubernetes, what's the main advantage? So it can fix the issues automatically. For example, if your application is down for some reason, first thing what it will do, it will try to resolve by itself. What it will do, first thing, it will restart the pod. So you will see that in many cases, you might have seen like the age of the pod, right? You might have seen the age of the pod. So here you will see the restart. So it's based on the liveliness probe. Okay. So if your health point,
Okay.
the health probe point that is down, and what it will happen immediately, it will check. So based on number, every periodic seconds, and then every like you have a retry mechanism also, and then it will check for that many times, and then it will fail. So fail means what it will do, it will immediately go and restart this application. You will see restart count 1 here. And again, if after 1 hour, again the liveliness probe goes down. So then again it will go and restart the same pod, restart count 2. And then you will see like when it got restarted, in bracket you will see like 36 hours ago or 24 hours ago. So that timeline also you see. I don't see an application that's getting restarted, but you will see it when you do it. So that's the importance of probe. Okay. So what's the difference between readiness and
Thank you, Lavanya.
liveliness? Welcome. Yeah. What's the difference between readiness and liveliness probe? I want someone else to answer. Maybe Chetan?
The difference is if the readiness probe is failed, traffic stops to reach the application, and if the liveliness probe fails, then pod is restarted.
Restarted. Excellent. That's what we wanted to understand.
I have a doubt regarding this. See, if the readiness in any of the probe fails, where we will get to notify about that? In logs or in pod section?
In the logs also you will see as a quick look, you can check it here as well. So in the restart, you will see a bracket symbol, and then you will see when it got restarted, like 26 minutes ago or 15 minutes ago, that timeline will be there. Okay.
Okay. And details will see in log.
Yes. So that's for the quick check that I'm saying, but you will not get all the details. So first last restart only you will see. The previous restart you won't see it here, right? For example, if it restarted for 10 times, but when it got restarted, you don't know the details. So that time what you have to check, you have to check your logs. Logs, how long it will store the logs in the cluster? Any idea? So whenever the pod is restarted, immediately the pod goes off. Then the logs might also be missed. So these logs are ephemeral, so it will not be stored forever. So maybe it's stored for maybe an hour or so. After that, you will lose the logs. So for that, you need to have a monitoring solution in place. Okay, so we will cover a monitoring session separately. So we will cover some Prometheus and Grafana for metrics capturing, and for logs also we'll see if we can cover Elastic Fluentd Kibana. So there you will see these logs, when it got restarted and at how many number of times and what is the reason for it. All these you will see it in the logs. Okay.
Sure. Thank you.
So I want to give you background on the application before going into the auto scaling session today. So the first, let's move on to the service back. So this is the cluster IP service. So this is scoped within the cluster. You cannot access this cluster IP outside of this cluster because your cluster only knows this. Nobody else knows it. So your external load balancer does not know your cluster IP. So your external world does not know about your cluster IP. Okay. And the other second type of service that we have is node port service. So node port service means, from the name itself you can see, so it is exposed on the nodes. that are running. For example, in our kind cluster, control plane is one node and worker node is one node. Okay. So it will run on these node ports. So you can access with the help of node ports IP, like node IP colon, and then 30,000 or 40,000. So there is a range. I think more than 30,000 and then less than 32,767. So this is the node port range. So basically you can access the service for some testing purpose. You can access with the node IP. So node IP colon 30,000 to 32,767. This is the range. So if you don't specify any of this range, it will get automatically assigned. So this is helpful when you do some testing. So you don't want to do the port forwarding thing every time. Rather than you just use the node port to access your application, but this is not a production case. You should not use it in production. This is when you test an application. So for that time being, if you want something to check, okay.
So I'm seeing only the K8 services. Are you referring to the same slide or different?
Yes, we are not seeing any example yet, but I'm just explaining.
Okay.
Huh? Okay. So the third type of service is load balancer service. So what is a load balancer? Basically a public IP, right? Public IP for your service. I have an Nginx application. Okay. I have an Nginx application. I can expose to a public IP and then I can access the IP and then send the traffic, right? So for example, I have another application called Redis or some other application. And then I can also expose it as a load balancer. And then I can access the application. But for how many application you will create a load balancer? So you will not create a load balancer for all of the service that you are creating in the cluster, right? So I want to tell you that we will not use these default service at all. These three services. Okay. So though it is there, we will use it, but in a different way. So cluster IP is the one that gets by default, it's assigned. So that's by default. You don't specify anything. You don't specify the node port for a production application. And for the production application, you don't specify load balancer service as well, because your load balancer is not secured. So you should not use load balancer just by creating a load balancer service. So that's also not a production ready. So what we will use? Basically, we will use an ingress, which will in turn create a single load balancer. Okay. So which will create a single load balancer. Using that single load balancer, we will do path-based routing for all the applications. So we have a dedicated session for this ingress service. So we will go through in depth on that day. Okay. I just want you to understand what's deployment, what's service. So that's why I want to give some basic details here, but eventually we will see that in the upcoming sessions. Okay, just understand what is the use of ingress. So we have seen in the last session as well what is the use of ingress, but still I want to reiterate in every session so that you don't forget it. These are the important concepts in the Kubernetes ecosystem. Without ingress, there is no production cluster at all. You have to have some routing mechanism. So you won't use the default cluster IP and load balancer to expose your application. Then what will you use? You will use ingress. So from using ingress, so behind the scene, it will create a load balancer. This ingress will create a load balancer. Okay, but you will not have hundreds of ingress controllers, right? You will have only one ingress. For example, Nginx ingress controller, you will have only one ingress and then one IP will be assigned. Using that single IP, you can handle your entire application traffic. For example, /video will send the traffic to the same IP, same load balancer IP, but /video, it's a path, right? And then /images, it will send a traffic. And then so whatsoever, images or whatever. So the path-based routing is there and TLS termination is there. So everything is handled using this. And of course, L7 traffic routing is possible with ingress. But we will have a dedicated session for this ingress, which is very important. So we will see that in the class. So I wanted to cover what's deployment and services, because those are the building blocks of your Kubernetes ecosystem. So now if I ask you, I want to onboard a new application, what are the files I have to have? Just tell me. Files means Kubernetes manifest or Kubernetes objects. So sometimes questions will be like, what is a manifest? What are the manifest file? What are the objects means? This kind is an object. So deployment is an object, stateful set is an object, config map is an object, secret is an object, and the namespace is an object. So these are all the Kubernetes objects. Okay. So now tell me, what are the files that you need for an application to run? Basic, bare minimum file.
Namespace, deployment service.
Okay. Yes. So that is what we have seen so far. But eventually we'll get into a production ready application. Then you will answer me like 7 to 8 applications. For now, you need a namespace, you need a deployment, you just need a service. So that's it, right? Yeah, I think that's enough for now.
Lavanya, like I do have another question. Okay. So right now I'm working in a company, okay, which is a software company, and they have their own product as a software. So, and each in that software, they have different functionalities. Okay, like one has the functionality of data uploading, and the other has the functionality of managing the users. The other functionality is of trust center. So all these applications, are they counted in one, or they are different application in one web application?
Okay, so these applications are not a single application. So it is, so from your explanation that I see, it is not like a traditional application. So it's not tightly coupled. So it is microservice based architecture. So it will be multiple application. Multiple application means multiple deployments. So if you convert it into Kubernetes language, it is multiple deployments. Okay. Each and every
Okay.
application are
And
microservice. So they
aren't the, got it.
Go ahead.
And aren't the company now moving back to the modular applications, like having one application in that they have modular functions as application?
Yes, they can segregate it into any number of microservices.
No, I guess he's asking microservices are turning into monolith.
Sorry, what did you say?
Yes. So these days,
I guess he's
companies
asking
are
microservices
moving back
are
to,
turning into monolith. Yeah, I heard an example of GitHub recently. I also heard.
so like the companies, to save the
Okay.
cost, instead of doing microservices, they are going back to the monolith application, in which they have the hybrid function of modular application. So that save cost as well. So I wanted to know if you have any idea on that.
Okay. Okay. But what was the reason to move back? Do they really need a microservice?
cost.
Because if it is a microservice, yes. So if you want to save
As
cost,
a
then you will
DevOps
not have
engineer,
all the.
okay, as a DevOps engineer, we even look into the cost as well, right? And we see like we need to reduce the cost of operation as much as possible, correct?
Exactly. But
So I was
moving
looking in
from
that
microservice
perspective.
so moving the microservice back to monolithic service is not going to help your application in the long run. So maybe it would save the cost and complexity of managing it. But when you want to scale your application, like have multiple microservices communicating to each other. So if it is a monolithic application, it's not going to be a small service, right? So it will be a tightly coupled application. If it goes down, your application will be down. If it's not about the cost, so it's about the application criticality as well. So if your application is not highly critical, it can go down also. So if that type of outage is acceptable, and then if you don't want to scale and you don't want to use all these microservice features like offered by the container orchestration tools, like scaling, probes, So you'll have to do a lot of work in microservice areas, right? So, but when it comes to monolithic, you just have a single strong application and then you use it. So the main factor that I would consider is not only the cost, but also the long-term health of the application. So then you don't need a Kubernetes itself, right? So you can host it as a monolithic service and then deploy it in a VM and then use it in a traditional way. So you don't need the container orchestration as well. So not every company, not every application needs a Kubernetes cluster, right? The reason behind is Kubernetes is very heavy to manage. So you need skilled labor here. Like we need expertise to manage the cluster health, to manage your application. People need to know what tools they have to use. They need to have complete idea about the architecture, designing, managing, upgrading. So that type of investment they will have to do. So yes, container orchestration is not for a small number of services, and also it's basically, I would say, a small company that runs 2 to 3 nodes. They should never use Kubernetes cluster. Okay, it's a waste of money, I would say. Just go to your any of your cloud and just go.
So how many nodes did you say?
Okay.
3 nodes or 5 nodes also, you don't need an cluster to run. So just to go for an alternative and then use it. For example, yeah, because 5 nodes means at least 1 node will be wasted. Default resource utilization like ODNS, proxy, everything will be coming by default. Do you need them? I don't know. So it's based on the number of microservices and how much your application will scale. So the important factor is based on the scalability, reliance. So these are the thing advantage of considering. Yeah. Okay.
That answer my question.
I think
Thank you.
I think before moving into the auto scaling session, then I think we will take a 10 minutes break because I think it's very late today. So I want everyone to be refreshed. Yeah. And then we will come back. 10 minutes break. So 9
Sure.
we'll see. Thank you. Hello. Are we back?
Yes, hi.
Yeah, yeah.
Okay. Is my screen visible?
Yes, Lavanya.
Okay. Okay, let's move on to scaling. So scaling means it's just increasing the number of pods or increasing the resource that's set onto that pod. So scaling can be increasing or decreasing the system resource so that application can handle the load. So that is what scaling means. So yeah, by now you know it better than me. So what problem it will address? It will address the load issue. So during the high traffic hours, it should handle the traffic without any performance problems. So that is what the scaling refers to. So there are different level of scaling in Kubernetes world. So basically, you can add more number of pods for an application. So if even we have seen in the deployment, we can configure replicas. Just increasing the number of replicas or decreasing the number of replicas, that's one type of scaling. That is called your horizontal pod autoscaler. So that is what this horizontal pod autoscaler will do, which is HPA. Okay, basically it is mainly for deployment and stateful set. So underlying resource that deployment or stateful set creates is the replica set. So each and every deployment will have the replica count. Yeah, so that replica count will be automatically adjusted when there is a load. So we will see how HPA example, like how HPA will be created with an example to understand it better. So for that, we need to see the memory. Okay, we need to see the CPU and we need to see the memory. So based on that CPU and memory usage only, you can scale. You cannot just like that go and do a manual addition. Like for example, I have a huge traffic now. So nobody is going to wake up at that point in time and then increase the number of replicas. That is manual scaling that we do on the deployment side. But that's not the production case, right? So we need to have some automatic mechanism to automatically scale when there is a load happening. So this is called horizontal pod auto scaling. So that does the job. So key things you need to remember is it is based on the metrics that is there in the cluster. So how much CPU, how much memory. So based on that, it is going to scale. So before doing the scaling, it will check the metrics. So that is a prerequisite for scaling. So your metric server should be working in working condition. So then only the scaling will work. So we will see how to configure a metric server and then how to visualize the scaling. Yeah. And of course, the key terminologies that they refer is min replicas and max replicas. So in the deployment, what we set is the static replica count. So for example, if we set replicas 5, that's going to be static. It is not going to change. When there is a huge load, it's not going to change. And that when there is no load also, it will still run. So that's your static replica. But we don't need that, right? In the production case, when there is no load, it has to scale down to minimum number of instances. For example, say 1. But when there is a load arises, it has to scale to 10 or 20 number of pods. So that is where this horizontal pod autoscaler comes into picture. So this is best use case for stateless application and web APIs. So if your microservice is a stateless application, so generally all your application scenario will come into horizontal pod autoscaling. Yeah. So this is widely used scaling in Kubernetes. So if you just visualize this architecture diagram in the Kubernetes cluster, if you deploy, if you create a deployment or a stateful set, which will create a replica set, and then it will have a static replica count in which is set in the deployment. For example, 4 means then it is going to be 4 for all times. So it's not going to change by default. But if you set a HPA for that resource, it will see the usage, CPU or memory usage that you are going to configure in the HPA, and then it will decide whether to scale in and out. So out means add more pods, in means remove pods. So yeah. Are we clear with the horizontal pod auto scaling?
Yes, conceptually.
Just understand the terminology. Yeah. Yeah. So let's see HPA example. So I'm creating a namespace. Okay. So what's the basic thing that we need? We need a namespace. And then I have a configuration for the application. So I have a config map. So in the config map, you will have only the configurations like server, like whatever required for your application. Yeah, like ports, service name, return ports, headers. So all the information can be configured as config maps. So that's another example that you can add in when there is a question like what are the manifests that you will create for a new application. Namespace, config map. If it is a sensitive value, create a secret. And then deployment, service. Deployment is your application. Service is for exposing your application. So by default, it creates a cluster IP. Okay. And then now comes the next step. You have to have horizontal pod autoscaler to scale in and out when there is a load that happens. Okay. So if you see the API version, it's autoscaling /v2. So just remember that at the initial days, this was never a V2. So initially they have started with V1 alpha 1, V1 beta, and then they will create a V1 release for it. Then eventually V2 alpha, V2 beta, and then V2. So this is not a single day. They have not attained at this level. So when the Kubernetes has evolved for last 10 years, these were also getting changed. So for each and every upgrades, this might change. So not necessarily that every upgrade. So maybe after a year or so, the same deployment will not work. That's what I mean. For example, if you create it with today alpha, and then after a year, you want to retry it, it will not work because there might have a lot of changes in the schema, and then API version might have changed. So yeah, that's what I want to share it with you on the API version. And it is a Kubernetes object. Okay. What object we are creating? We are creating a horizontal pod autoscaler. Yes.
Lavanya. So if we use previous version, so the Kubernetes will not work.
If you use previous version, so they will support having a deprecated version up to for example, so today we have 33 version, right? 1.33 Kubernetes version. So I have V1 alpha in my application. Okay, I have used V1 alpha in all my deployments. Okay, V1 alpha. But in 33, they said we are going to deprecate V1 alpha 1 after like version 35. So they will just notify us. So they are not going to remove it on every release. So they will give ample amount of notification. So you are not going to do an upgrade without reading the release notes. So every time you do an upgrade, you have to read the release notes and see what has been deprecated, what has been newly added. So there they will notify that this is going to deprecate in version 35. So that means it's not going to stop working from the day you do an upgrade. So it is going to stop work when you release 1.35. Okay. So until that time, this will work. But after that, this HPA will not work. So you will receive error, like it's invalid or something. Then you will have to check and then change it. Okay.
Okay.
So this is the horizontal pod autoscaler name, and then where it is going. It's going in in this namespace, HPA testing namespace. So this is one of the important factor that you need to understand. So what it is trying to scale, it's trying to scale this deployment. So it's checking this API version and just goes and checks the deployment with the name HPA test app. And then this is the HPA test app. So this horizontal pod autoscaler is for this deployment. Okay. And similarly, each service will have a selector that's for your app, HPA test app. So based on the label only. So that's the use of label. Okay. So label is for naming the deployment, and selector is for selecting that deployment. For example, I named the deployment with HPA test app, but in the service and in the HPA, you are going to use the label. Okay. Sorry, use the name. So that's your scale target reference. So you are going to scale this deployment. So what's your minimum replicas? 1. What's your maximum replicas? 10. So when there is no load, it is going to be 1. When there is a huge load, it is going to scale up to 10. And then metrics. So based on what? Whether it's based on CPU or memory. So here you need to configure. So if it's based on CPU, if its average utilization is 50, then it will wait until it reaches this utilization limit that you have configured. If it exceeded 50 or if it exceeded 80, then it will scale. So it will scale one pod and then again checks the average utilization. Then again scales another pod if it exceeds. So when it will stop, it will scale up to 10 replicas and then it will stop. So again, if there is a huge load after 10 replicas, this is not going to work. So it is configured to have maximum replica up to 10. So this is a hard limit here. It cannot go beyond that. So you will have to decide. So why do we need this limit? Sometimes your application can scale unnecessarily due to some problem with your application, due to some leakage in your application. So it can go and schedule up to 10 pods. But after that, it cannot scale. So to have that limit, we have this max replicas. Otherwise, it goes on and then it can schedule up to 100 pods. So that's on the metrics. So this is important to notice that it can be memory also. Yeah. So these are the type of metrics that we use. And behavior for, so we have, these are advanced configurations, like how long it has to wait for scaling up and how long it has to wait before scaling down. So for behavior, so for scale up behavior, stabilization window seconds. So wait, for example, I scaled one pod. So I added pod number 2. And then before it is even stabilized, it can scale another pod, right? So you can give a stabilization window of 10 seconds or 20 seconds and then start with the other pod. So this is that stabilization window. And then percentage is like how much percentage it has to scale. So it has to scale for 100% with a period of 15 seconds. That also you can configure. Do we really need 100%? No, right? We might need some 20% of scaling only. So that type of percentage you can configure. Okay. Yeah. So it can be either in pod percentage or it can have the count as well. So you can configure both either of these. Yeah. And yeah, select policy is max. So max number of pods. Yeah. And scale down is the scale down behavior. Like when there is no load, so this setting is matched. So it will wait for the stabilization window and then it will scale down 50% at a time. Not from 10 to 1. So it will go from 10 to 5 and then 1. Yes. Any questions?
Yes. So if you have completed explaining it, I have one question.
Hmm?
Can I go ahead? Can I go ahead?
Yes, please.
So, okay. So I explained one scenario earlier, right? So this is where the same case comes into picture. When we enabled HPA, The HPA didn't scale it down at all. Minimum pod is 1, max pod is 70 or 40. Okay, let's say 40. Minimum 1 and max 40. And the factor is on the JVM, since we have set a 40, 80 min max JVM utilization, segregation.
Okay.
Where the bottleneck happened was here on the pod level, we have kept scaling, HPA scaling based on both the CPU and memory usage as 50. Once it reaches more than 50 or 60, we kept it as it should auto scale to the number of pods that we have set. Since the memory is already taking up 80% of the pod, JVM memory is taking 80% of the pod, the overall memory utilization is already high. Then HP thinks that, okay, the utilization is very high. Now I need to start scaling up to throttle the max pods. So ideally, it always runs on 50, 60 pods out of 70 pods.
Okay.
Though the traffic is still normal.
Okay. Did that had a scale down behavior?
Yes, I did apply this behavior policy also. But eventually it didn't come down. It didn't scale down only because the memory didn't come down itself.
Yep.
Because the allocation was wrong. Meaning, though the JVM is not holding up memory to more than 80, but still the allocation was kept minimum as 40 and maximum was 80. So which eventually didn't allow this HPA policy to scale down even with the behavior policy.
Okay.
You got the point, right?
Yes, I got it. So that means your application was always scaling up because your heap is always consuming it.
Yes, I mean the allocation of heap is always consuming it, though the JVM utilization is less. So which means the JVM allocation setup was wrong.
Yep, that's a very good use case. Yeah, thanks for sharing it. So these are one of the primary use case that you need to consider. So how it has to scale. So what you can do, you don't need to mention CPU and memory. If it has a custom metrics also, you can configure custom metrics from your monitoring tools like Prometheus and Grafana and create a custom metrics. And based on your custom metrics, you can watch it. You can watch and then you can scale. Not necessarily always CPU and memory. Okay. You can rely on external factors as well.
Okay.
Okay, that's on the HPA. I think we can finish the theory and then we can go with the lab. Yeah, I want some volunteer to do the lab today. Let's see. Yeah. So are we clear in HPA?
Yes.
Yeah. So now you have to add one more file in your onboarding application. So namespace, deployment, service, HPA, right?
Yes, and config as well.
Config secret.
Lavanya, can you once explain the config file which you have showed up there?
Sure, for sure. So that was not the intent of this class, but I just want to add the file. Yeah. So why do we need a config map? Are you from application background? Any of you? Anyone from development background? No, is it? Okay.
No.
No worries. So for example, for any application, you will have a list of configuration files. Okay, let me pull up a configuration file.
Is it the environment file?
Yes, config file, env file where you will have key pair values.
Yes, we have every application.
Then if that is the case, then we shouldn't expose this, right?
So this is the config map. So config map is not for secret handling. It's only for non-sensitive values. For example, any resource name is non-sensitive, but any password or database or IPs, those are sensitive information. So you need to categorize what is non-sensitive and sensitive, and then for non-sensitive values, you will use them in configuration. For example, if you see this, it's like a like config file.
Variable.
Yeah, like it has a lot of sections like JSON kind of formats. Not a JSON, but yeah, it's a config file that you will call this and then pass it to your application directly. Your application has ability to read this default.config. In that case, you can config the server, you can config these values in config map, or you can just you can also have something like DB name. Redis. Yeah. So you can configure your Redis application DB name, and then yeah. So can someone explain some of the configuration, like what and all the configuration that we can pass in app name or something. So these are config maps. But what are secrets? Secrets are for storing the database password, IPs, and what else?
APIs.
Yes. Yep.
Yeah.
Yeah, much more. So basically, to config map is for storing the configuration details. Yeah, cloud credentials. All your cloud credentials are configured as secrets, not as config map. So you got the difference between your config map and secret, right? Oluka, is it clear?
Yeah, it's clear. Thank you.
Okay. So you can add in these two manifest every time when you say config map, secret, deployment, service. Now you have one more HPA. Yeah. So now moving on to VPA. So HPA means adding more pods, right? But if your application is a database, adding more pods will work. Do you think it will work? No, right? So your transaction is being, for example, if your transaction is handled by that current running pod, having a new pod will not work, right? So in such case, we might have to increase the resource request and limits onto the pod so that it can consume additional compute resource, and then it will survive to handle that load. So for that type of scenarios, we will use vertical pod autoscaler. It's not scaling another pod, it is scaling the same pod. Okay. So basically what VPA will do, it just adjusts to the existing resource request and limit. So based on the configuration that you give in the VPA, it is going to increase the CPU and memory onto that existing pod. So the use case, why we need to increase onto the same pod instead of running a new instance. So for example, if a transaction is being carried out for a financial application, then in that case, it is must to increase the same pod's resource. So in that type of scenario, we will go for VPA, vertical pod autoscaler. So there are different types of mode. Off means by default, it will not always enable. So if they require, they can enable it with option auto or initial phase. So basically, if it's for non-prod environment, you can keep it in off mode. And then if it's for a production and critical application, you can keep it auto mode. So it will always, if there is a huge load, it will automatically handle your application. Okay. So what is the use case? It's based for the batch jobs and then for services with stable patterns. So for example, if I have a batch job, so that's it is executed once a week. It is very intensive. So for example, it does some data migration or whatever, or fetching the details from somewhere else, or running some cron configuration on a weekly schedule. So in that type of case, it might require additional resource. You don't need to spin another pod and then do entire stuffs again. Instead, you just increase onto the same resource. So that's where your VPA use case will come into picture. Okay. So again, VPA changes the request and limits, not the replicas. So just imagine that you're not adding one person, just increasing the capability of the same person. Okay. That's what your VPA is. So for this also, it has to observe CPU and memory consumption and then analyze it based on the setting that you set, and now adjust the pod. So and the changes are applied. Yeah. So previously, every time when you change the CPU and memory, I think up to 1.32 or some version, pod will go for a restart. So there were no mechanism of utilizing this feature full-fledged in the previous versions, but now it just on the fly, it increases the resource limit and request on the fly. It's not going to restart. So that's the latest update. So that's why this feature was not widely used, I would say. But now it has more advanced. It has come in with more advanced option, like it can just change the resource request and limit on the fly without need to restart it. Okay, so that's the use of VPA. And we will see another example for VPA. Let's see. Yeah. Again, your namespace, your deployment, your service, and your VPA. So again, it is belonging to the autoscaling family, and then object is vertical pod autoscaler. So I'm giving only few, I'm just giving only few parameters here, right? But if you want to see all the rest of the parameters, what and all it is supported, how will you check?
Sorry, repeat again. Didn't understand.
Just a minute. So in all the examples, I was not covering all the parameters that vertical pod autoscaler supports, right? So
Yes,
only
yes.
few parameters I'm discussing. So doesn't mean that it stops here. So you can explore it from the
On documentation.
document. So another advanced thing that you can refer is in the custom resource definition. So these are the parameters it supports. Just take it and give it to ChatGPT. Ask him to give an example covering all the parameters. It will give you all the options. So previously, what we used to do before 5 years or 6 years, so I used to read each and every parameter. Okay, just and then sometimes if we don't set it at the right configuration, it will fail. So sometimes it supports in beta, or then if they change it in V2 version, it will not work. So what we do, we go and examine the CRD and see what parameter it supports and then change accordingly. So now you know where to check, right? So for any resource creation in the sense, any kind creation. So just go and check the CRD, respective CRD. So full CRD schema you will have. Okay. So these are all the supported parameters. So apart from this, there is nothing else. So yeah, your ChatGPT will not give you a very good example covering all these values, but your CRD will give you. Okay. So that is the major use of it. So I learned it after 5 years. The first 5 years, I was checking the Kubernetes documents, and then I didn't know like all the options. So I only checked the Kubernetes document. Yeah. So this is the value. I didn't know rest of all the values. So it took some time, like years, to analyze these CRDs. Then once you understand it, then it is piece of cake for you. Just see this and then create the resource accordingly. Are we clear? So we have seen another resource called custom resource definition, which is called CRD. So the command to explore is kubectl get CRD, custom resource definition also Yeah, can be given. So this is an alias. Okay. Clear? Any query?
Yeah,
Yes.
sorry, any use case for this CRD? Sorry, maybe if I missed.
Okay. So can someone explain?
Maybe CRDs are the basic units how objects run based on CRDs.
So why do we need to analyze CRD?
In order to get the all the parameters that are applicable to any particular object in the Kubernetes. Like here we are using vertical pod autoscaler object. So for that, if you want to see what and all are the parameters that are available to apply to this.
Yes, exactly. Is it clear?
Yeah, thank you.
Thank you, Ganesh. Yeah. So this is the update. So this is the target reference. So for which resource we are targeting and update policy mode, whether it has to go on an auto, like it can apply or evict or delete. So auto means based on the load, it will work accordingly. So you don't need to do any manual steps. And then resource policy. So it's for all the containers. Check the CPU and memory. Minimum allowed is 2, maximum is 1. So it can start from 2 and then eventually increase. So there is an option to increase, I think 50%. So it does not increase in one go. So those values, you can just check it in the CRD and get the parameters and then update. So now you know how to explore it further, right? For any
Yes.
configuration. Clear?
Yes.
Super. So any query in VPA? And can someone repeat what is the use case of using VPA? Yes.
If we don't want to increase the other servers or other machines, instead, if you want to increase the load on the same machine, where if we are running any cron related jobs like batch jobs or in the database node, then we can go for the VPA just by increasing the existing resources.
Exactly. So just to rephrase, don't mention node, mention it as a pod. Okay.
Yeah. Okay. Thank you.
Okay. Thank you so much, Monica. So comparing HPA and VPA. So by now you know what it does. HPA, number of pods. VPA, adjust the same pod, more pod, bigger or smaller pod. Okay. Primary goal is spreading the load. Here, increasing the same load. So someone asked me, what will happen if it reaches the limit, memory limit, right? So then what will happen? It will go on a OOM kill. So to avoid any application receiving the OOM kill, you can configure VPA. Okay.
Yes.
So now you know how to deal the problem. And what is the prerequisite for watching this? You need to have a metric server up and running. So by default, every cloud offering, they will have metric server. If not, also we can configure our own metric server. So which we will see it in the demo. Yeah, how to watch? Yeah.
Yeah, I had one question.
Yes.
Like on a pod, if different applications are running, then each application, if we have to give a different auto scaling, like for application 1, we have to auto scale the servers based on the CPU, based on the matrix, like maximum replicas will be 10. But for application 2, we don't have to keep the count similar to application 1. Then in that case, we will maintain a separate files, right?
Exactly. So what we were seeing. So this is consider this as an application 1. Okay, this VPA sample application 1. So it is only doing vertical pod auto scaling. So the requirement of the application is to have VPA. So for this application, we will have VPA configuration. So, but for the other application, I had HPA. So it is two different application, two different configuration. So how it selects which application? It selects based on the deployment. Okay, like, sorry, target reference. So now you have selected this deployment. So who is your target? Based on your target reference. Okay.
So we can add the second application, so we can give it as a target reference too. Means we can add a section.
No,
in the
it's
same
one
file.
mapping. You cannot have VPA, one VPA for multiple application configuration, one-to-one mapping.
Oh, sorry, can you repeat?
So for each and every application, you need a separate VPA configuration. So it is one-to-one mapping. So for application 1, it has to have a separate VPA. Application 2, it has to have a separate VPA. So you cannot have one single VPA and control two applications. Is that what your question, Pranya?
Yeah.
Okay, you need to have a separate configuration for each and every deployment or stateful or stateless stateful application.
And I have another question also. Like as a DevOps engineer, if I have to create this file on my own, then the sequence will be the same, right? The parameters that we have mentioned from the beginning to the end.
So sequence means, are you asking like first you'll have to create a namespace like that, or?
Yeah.
Not necessarily. You can keep it anywhere. Okay. It handles the dependency very well. Okay. You can do it like this. No problem. Okay. So that is what. So there is no sequence thing. So it just checks and applies. The order and sequencing, it takes care. So all that you need to do is kubectl apply, and then your API server will take it. Okay. So it is not necessarily that first it has to have namespace. Like it's not necessary first configuration should be deployment. But without deployment also, you can just create a dummy service. No problem. So the thing is, no obligation will be exposed. But this application service can be created. Okay. But so once you create a service today, then you are investigating, your application is not running. Then you did some misconfiguration in deployment. That means your deployment was not there on day 1. So on day 2, you are creating the deployment. So still until day 1, your application was down. On day 2, your application is up. So that means it can run without that. It can run without the deployment also. So dummy deployment can be there. Like dummy service can be there.
Okay. And one more thing, like what are in this entire file here, what means, where are the parameters, application related parameters that I need to confirm with the application teams? What are the parameters?
So actually you are providing the sample files to them. Okay. So they will have to fill in the details. So here you're giving the container name as Nginx. Okay. So they will have to replace it with their application, but you have mentioned the port here as 80, but they will have to reconfigure with the application port. So you are not going to give this template and ask them to use access. So based on their application configuration, you're just giving a template to them, and then few things that we discussed today, like readiness probe and what else? Liveliness probe. All those things we discussed, those we can enforce them to use. So enforce means they can change the values. So only thing is you are giving the template. So they will have to, application team's responsibility is fill in all the parameters that the application requires. Did it answer, Pranya?
Yeah.
So you are not going to create all the application by yourself. So they will have to fill in all the details. And then this, by default, they will not come to you for every deployment. So this is handled in CI/CD pipeline. So in CI, they will create a Docker image, and then they will push it to the container registry. So by the time they push it, they have the container name already. So just they will have to configure the rest of the parameters. Okay, how much resource request. So these and all, you cannot set it on day one with right values. So this will come eventually. So basically you will start from minimum resource request, and then eventually if you see more load, then you will increase it. So you will monitor for 1 month and then call your application stable. So basically you will have to start allocating from small amount, and then you will have to enforce the application team to have the right probes. So those things are responsibility of DevOps team, but managing the application is application team's responsibility. Did that answer, Pradanya?
Yeah.
Okay. So DevOps, it's
I
all
have a doubt.
a bridge. Yes, Chetan.
Yeah. What will be the best industry practice for auto scaling the application? We should go with HPA, VPA, or combination of both for an entire application? I must.
Yeah, wait for some more time, Chetan.
Oh, sure, sure.
Maybe can I answer? Look, like it depends on the, like as you said, the use case, right? If it is like DB or cron job related, then we'll be going for the VPA.
Yes, yes. For stateful application, VPS, and for stateless, HPA. So combination of both will be the best industry standards for an entire application.
No combination of both will not be for the same resource. If that's if you are referring that, so you cannot have a VPA and HPA configured for the same application.
Application, I mean to say the entire app. It can have multiple services like database or front end, back end.
Yes, for each and every application, based on the need, you will either have HPA and VPA. But if you have a combination of these for the single application, then there will be a conflict.
Yeah.
HPA will scale up and increase the resource, and then your HPA will increase the replica count. So yeah, so there are pitfalls. So choose the right thing which is needed for your application.
Sure, based on requirements.
Right. So anyways, I have shared this document. So you can go through the comparison. I don't want to go line by line because we have already covered pretty much everything. So node auto scaling. Okay, so let's see node auto scaling. So far we were seeing pod auto scaling, right? So your pod is auto scaled. So where it will be scheduled onto the node. So for that you need to have a node, right? Free node should be there to schedule. So how that happens by default? Through node scaling. So who does that for you? Cluster Autoscaler. So this cluster Autoscaler are provided by cloud because in on-prem you need to have a different mechanism to scale them, not the cluster Autoscaler. There are a lot of tools to do that in on-prem, but for cloud-based environment, so there is an inbuilt cluster Autoscaler that comes in picture, and then you just set the minimum and maximum count. So 1 to 100, 1 is minimum and 100 is maximum, because now you are starting your cluster with a minimum load, so you have configured just 1, for example. If there are more loads, then it can reach to hundreds of nodes as well, right? So how it will eventually reach to that point? So cluster Autoscaler will evolve. So basically it starts from 1, and then if there are too many application teams onboarded to your cluster, then it will be maybe 10 or 20 and eventually increase it to 100 nodes. So how that is done? So you are not going to do that every day. So you are not going to do every day like manual scaling. It has to be done automatically. So node scaling. This cluster auto scaling does that. So how it will get invoked? So just see this diagram. So for example, we had HPAs, right? So I had 1 minimum replica and I'm getting huge load. I have configured 100% of scaling. So which means I have to schedule 10 more pods. So do you think 10 more pods will be immediately scheduled? Any guess?
No.
No. Why?
No, I guess.
Because
node is
limit-
not there.
yeah.
Yeah. If node is there, it will go on schedule. If node is not there, it will go on pending state. Scheduler is still checking to find which node is available. If the node is not there, so the pod is in pending state. Now your scheduler is checking, there is no node. Then comes in your cluster autoscaler. So cluster autoscaler receives the request for new node provisioning. So it's based on pod goes in pending. So it's a reactive method. Already problem is there. Okay, pod goes on pending, and then cluster autoscaler receives a request. Now it creates a new node, and then new nodes will be provisioned for, and then your pods will be scaled on to the new node. So this is how cluster autoscaler will work. Is it clear?
Yes.
Okay. And this, so this is for scaling node. But scale down will also happen. So the load is reduced. So the pod goes back from 10 to 1. Now you have a new node spinned up to for that 10 pods, right? So that node will be down in some time. Okay. So again, the cluster autoscaler checks, like if there are over provisioned node, then it will choose that specific node, and then it will, if there are few other pods, like 1 or 2 pods that are there in that node, it will try to reschedule those 2 pods, and then it will scale down that node. Okay, so that your cluster will be well balanced during your load, high load, and also in underutilization also. Clear?
Yes.
Scale up and down. So basically this will work in cloud. So if you see this, every scaling has a pros and cons. Okay. So based on the need, for example, this is reactive measure. So for quite some time, your application will be down. So pod goes in pending. So node provisioning, maybe it takes 2 minutes. So that 2 minutes, is your application is okay to be down? No, right? If it's your critical application, finance related application, then you will incur loss, right? So for those things, there are few other tools, okay, like carpenters and all. So those does a better node provisioning than the default cluster autoscaler. Okay. So
Yes.
moving on to the next scaling. So pod is scaled, okay, virtually, okay, not in the real time. Just imagine we have done the pod scaling, node scaling. Okay, so there are other factors of scaling as well. So you have your database, or you have your Redis, or RabbitMQ. So you have your Kafka, which is receiving a lot of events. So based on those requests as well, you can scale your pods. So the metric is not within your cluster. The metric is coming from outside your cluster. Okay. So the outside your cluster means from where? From RabbitMQ or Kafka, or even from the Elastic. So how many number of queues are there? So based on that, it will scale your application, and then it will execute. It will consume that like number of queues that are there. Okay. So to consume that, it might have to scale the pod. So external factors are there. So based on the event that it receives, it will scale. So that's called as event-driven scaling. So this is not an inbuilt concept of Kubernetes. So this is an external tool. So it's a CNCF open source tool. Then you need, if your application is having such requirement, you better make use of this KEDA, event-driven scaling. I have an example for this. Maybe we will cover that in the demo. So basically, when this will be useful, in case there are some consumers, so if there are huge load onto the RabbitMQ, you need a lot of consumers. In that case, this will be helpful. Okay. So I have 1 million records in the RabbitMQ, but you have only five consumer pod. Okay. You want 100 consumer pod to consume those millions of resource like request that's there in the queue. So for that, we need event to be sent, and then based on that event, your pods will be scaled. Is it clear? But underlying concept is HPA. So it will scale. HPA is the thing that's running underlying the KEDA. So because it is adding number of pods. Okay. So not just CPU, not just memory, but for events that are coming outside of your cluster. Yeah. So these are some of the events, event source generators. Okay. So another example of node scaling is Carpenter, which I said. So what we have seen, so node provisioning is faster compared to Cloud Autoscaler, because in Carpenter you have you will choose like list of VMs. Okay, so 4 to 5 VMs you will configure, like MX large or small. These type of VMs, if you choose in the Carpenter configuration, it just spins up in less than the cluster autoscaler time. So these node provisioning time is faster compared to others. So basically, this Carpenter is the was built by AWS. Now this Carpenter is adopted widely in other clouds as well, Azure, and even for rest of the clusters like managed. I don't know if it works in on-premise as well, but I know that in the recent time it is adopted by Azure as well. So yeah, so basically you configure 4 to 5 list of nodes. From that nodes, it will scale up. Okay, so that's the real use case of Carpenter. It is one of the node scaling. So let's see, because I don't think we can do this demo because we need a cloud. If someone has a cloud account or test cluster, then we can see how we can do this Carpenter type based scale. Okay, let's see that. Maybe in the class, if we try to create a cloud-based node, let's see if this is possible there. But now you understand that we have Carpenter for such scale. So gateway, so this is not for today, this gateway API architecture. That's for the upcoming session. Okay. So now let's discuss the use case. So when to use what? Okay. So by now you would have understood when to use HPA, when to use VPA, when to use Carpenter is basically for node provisioning. So you will define set of nodes, and then from that set of nodes, you will provision the node when there is a demand. Okay. So basically it was built in AWS, then it was eventually adopted. KEDA is for based on external event-based scaling. So one use case is RabbitMQ. Okay. Yeah. Any questions? I heard some voice in between. So what's the difference between Carpenter and the cluster autoscaler? So cluster autoscaler, what it will do, it will only scale that specific size. Okay. So I have created a cluster, and then I have created a VM type like node pool or node group. They call it in different cloud environment. And then whatever node size you configure, so that size will be scaled in cluster autoscaler. But when it comes to Carpenter, as I said, in Carpenter, we can choose list of sizes like MX large, small, medium. So different sizes we can create in the configuration, and then based on the demand, it will check if small size nodes are okay to handle the load, then it will only schedule that specific node type. Okay, that's basically we can say like right sized nodes are provisioned dynamically with Carpenter. Okay.
Yes.
And the main use case of carpenter is cost. So not necessarily we need high-end machines for all the resource requests. Like for example, someone quoted batch job, so it's going to be on demand, right? In that case, carpenter can spin up maybe a big node as well, and then it will just do the job, and then it will scale down. Or for a small cron job, like it just runs with very few compute instances. Just it can scale a small node, and then it will do the work, and then it will scale down. For such requirement, so you don't need to spin a high configuration machines, right? So that is handled with carpenter. So mainly it will solve your cost, like it will reduce your cost. So it does cost optimization. Okay. So it's best to fit for carpenter is spiky workloads. So if there are huge load at specific point in time, carpenter is your best use case. So and your diverse compute needs, if there are spot instances, those can be used in your carpenter configuration. Spot plus or also on demand. So what is spot? Spot means every cloud will offer VMs at a very discounted price. So I have a product that's not been sold for years. Okay, but it might be sold, so I cannot wait. I need to make some money on that product, right? So what I will do, I will give those product in lease. Okay, maybe they can consume it until you have a right customer to buy it for high cost, right? So maybe you will give that product at a discounted price. So that's called as spot. Clear? What's spot?
Yes.
So Azure and AWS will offer spot instances because they have built the data centers and all the compute instances are there. So they will wait for the customers, right? Instead, what they will do, they will offer those spot instances at very cheap rates. And then people like us, if we have a use case, we can make use of that spot instance. The one major problem with the spot instance is if there is a high demand. So they can redeem this capacity and give it to the customers. Like if they need a capacity back, they can take it. So then you will lose that VM. Okay. So you need to always have a fallback mechanism to on demand. So on demand means your normal machine will have the right pricing, not like the discounted pricing. So you need to find the right product. Okay. You pay the right price and get the product, not a discounted cheap ones. But discounted cheap ones are for short-term usage. Clear on the terms of spot and on demand. Is it clear? So these are cloud terminologies, I would say. So spot and on demand. On demand means so any VM that is given in pay as you scale model, it is on demand. And then if it is on the cheaper nodes at a very discounted price, it's the spot instance. But if they need the capacity back, they will reclaim the spot instance and you will lose. You will lose the spot instance. Okay. Is it clear?
Yes.
Thank you. So with that, I think we can jump into the demo.
Yes. Yes.
Super. So you have the week three details, right? I think I've shared it in the WhatsApp. If you don't have, it's the same GitHub link that I shared last week. So week 3, I'll put that in the chat. Please, everyone, start your kind cluster if you have already. If not, this lab should have the details how to spin up kind cluster. So I want everyone to make use of this lab session because we are spending around 1 hour in every session. So the class is only for 1.5 hours. So most of the times we don't need to sit idle. Everyone has to try the lab. And then you will come up with question. I see this group is currently active for all the queries, right? So if you all do the lab assignments, then I think you will have more questions. So then we both will benefit. Share the GitHub link. So this is the GitHub link, Abhishek. So we share the GitHub link. So each and every week has a README file with the instruction. So we spin up a kind cluster and we do the demo in that in that kind cluster. So
Yeah,
every
okay.
week is independent. You can spin up a kind cluster from scratch and do it.
Okay.
Okay. Can someone share? Because I can do it because I have tried this lab already. I don't want myself to explore the lab again. I want someone to do it, and also I want to see if the lab works. If not, I can fix it right away so that it will be useful for others. Yes, who would volunteer today?
How
Chetan?
can I set up the lab? Because I didn't set up that.
Okay, so is it your first session?
Yes, kind of.
Okay. So do you use Windows or a Mac machine?
It's Windows.
Okay. So if it is Windows, you need to enable WSL terminal. So in future,
Yeah, I have that.
you have that, right? So in
Yeah.
there, your kind cluster can be spinned up. No worries. So open the terminal and then just run the command, and then it should work. Have you installed KubeCtl?
No.
kubectl? Okay. Then what you do in the WhatsApp group, there is a lab requirement guide.
Mhm.
So which says what and all CLIs you need to install. Okay, so just
Install
complete
that.
it before, just complete it before coming to next class. So basically, it has Cilium installations, Cilium CLI, and WSL installation, and Terraform, kubectl, Helm. These are the tools that are required for the lab. So just go through it.
Can you tell me in short what is Cilium and why we require that?
Which one?
In short, just overview. Cilium.
Okay. Yes, I will tell you, Chetan. Just give me a minute. So I want someone to drive this lab, then I will, respond to your query.
Sure, no worries.
Okay.
Shall I?
Yes, please. No worries. Don't be shy. Like we can take more time also. Like we have half an hour time to spin up. Okay. We can run the lab in the existing cluster as well. But would you mind creating a new cluster and
Yeah.
Thank you.
Sure.
So just copy it from the README.
I'm just checking.
kubectl config get item context.
Yes. So you are creating a kind cluster now. So Chetan, we use kind CLI to create kind cluster locally. So for every
Yes,
lab,
yes.
we run this kind cluster. Abhishek, for you as well, if you are here. Yeah.
Yeah.
We use kind CLI to create the cluster.
We are creating two nodes, one for worker and one for control.
Yes. So you have to navigate.
Yeah, I don't know why I'm getting error. Deleted nodes, Autoscaler. Every time it's the something. Reach target multi-user system detected secret failure.
Okay, but if you have the existing cluster, you can run it. So I don't think this is a problem. Maybe someone else could try to see if the kind cluster creation works. So it's not the new file. So we used to have every week. Just navigate it to this folder, then it should work. Yeah, Kodika, because this folder has metric server.
Okay.
So navigate it to this GitHub. Yeah, clone this GitHub.
Should I have to?
So metric server is the prerequisite for watching the CPU and memory. So can you run kubectl top command? Kubectl top space nodes. So it will take some time. So without metric server, you don't visualize the utilization of any resource. So that's the reason why we are installing the metric server. Yep, it is running. Maybe check now. So do you have K9S?
Yeah.
So now it is getting up. So before it was saying that some different error. Now it was saying some different error. So we have metrics, node metrics, but it's still not able to handle the request. Run the K9S. So this is one of the CLI tool instead of running.
Okay.
No worries, no worries. So just install, yeah, in the next class so that you will have a better visualization. So instead of kubectl command, you can do the same action using K9S tool. So it's a utility. It can be installed in WSL, Mac terminal. So just install it. Yeah, maybe before coming to next session, Abhishek and Chetan, or rest of others who does not have K9S. So you will definitely like it. It's very fast. You don't have to
I'll
search
try.
for kubectl get HPA. So yeah.
So are we going to have a lecture on Saturday and Sunday this week?
Usually we have Saturday and Sunday. So 1.5 hours on Saturday morning and 1.5 hours Sunday morning. So that is the plan. So last 2 weeks it was like that. But this week I wanted to do it only on Saturday, combining both the sessions for 3.5 hours. But I think someone has requested a Friday session. I don't know from this group or I'm not sure. So there was a vote happened and then it was decided.
Okay, so tomorrow there will not be
So
lecture.
there is no class tomorrow and Sunday. So we
Okay.
are covering the entire session. Yeah, the entire week's plan today.
Can I share, Lavanya?
Yeah, you can. Sure.
Yes, please. Yeah, I'm very happy if someone.
Actually, I have installed that on my WSL, but my system is getting hanged because if I start running the Docker. So I thought of creating a server, one VM, and doing all this. That's why.
Okay.
Yeah, I guess it's even better. Create on VM instead of on platform.
Escape colon. So you know how to navigate K9S, right? type pods, PO pods. Yeah, it will show you intelligence. Type 0 for all. So in the above, it will show what are all the shortcuts. So 0 means all namespace. Okay. Right? So deletion, describing logs, executing into the application, it's also easy from here. So use this K9s every now and then. So now we are going to see the HPA. You have deployed HPA as well, right? HPA.
Oh, yes, Lavanya.
So that's fine. Just to go back to your kubectl. So pull up another screen. And then run the test connectivity.
No, Cilium? No.
No.
Which?
Go to the readme file. Go to the readme file. Can you do it in code instead of preview mode? I think I don't know if I did it correctly. Okay. So where were we? You installed the metric server. So we were able to see run the top commands, right? So you installed the HPA as well. So now run this test connectivity. Just copy this.
No,
And
line.
yeah. Line number 23 and 24 all together. So basically, this is going to create a load onto your HPA app test application. Okay, pull up another screen. And now see the number of pods.
I don't see any new pods coming up.
Okay, sorry, I was on mute. Can you run the 28 and 29 line code from the GitHub? Yeah. So we did a test connectivity and now we are running a load. Okay.
Yeah, now.
Now,
Yeah.
yeah. So it is creating. So what did we do? First, we created a kind cluster and then we deployed a metric server. So after deploying the metric server only, you can see the CPU and memory utilization of nodes and pods, everything. Okay. So then what we did, we deployed a HPA application and then we did a connectivity test and then now you are running a load test. Okay. You are giving more load to the application and then it will scale up to the max replicas that we have provided in the HPA. Go back to your HPA file. So from the GitHub. So yeah, HPA, yes. So this is what we were seeing, right, in the session. Come down. So minimum replicas is 1 and max will be 10. So it will eventually scale 10 pods and then we'll stop there. Okay. So this will happen behind the scenes. We don't need to do any action. So all you need is just configure HPA and configure the count. Okay. So if your load test execution is completed, it will scale down based on the scale down window that we configured. Okay.
Okay.
So that's on the HPA. Maybe you could try VPA as a lab assignment. Just go to the KEDA because we have only few minutes left. Yeah. So now you understood the concept of HPA, right? So similarly, VPA will work. So just explore it yourself. And then now we are going to deploy KEDA. So go to the README again. Okay. KEDA section will be there. Yeah. Here 129. So basically, we are using Helm CLI to install KEDA. Do you have Helm CLI installed?
Yes.
Okay, super. So this is not inbuilt tool. Okay, you didn't deploy anything for HPA. But for VPA, it's not coming out of the box for kind cluster. We'll have to do some configurations for VPA. But just understand the concepts and then try the lab yourself. So now what we are going to do? We are going to create a load test for KEDA. So based on the event scaling. Did you deploy the KEDA YAML?
Sorry.
Yeah, I think you deployed the KEDA YAML already. Okay. So where are you now? At the
Creating an event.
Okay. Can you view as code? Yep. Run the 144 line alone. Yeah. So you have the Redis server. Okay. So now you are sending batch jobs using Redis CLI. So you are creating an event. That's it. Okay. Yeah, you are into the Redis. Yeah, just to copy from line number 147 to 152. Just paste it multiple times. So it is creating a lot of events. Just create more and more and more. Yeah. So now go back and check the scaling.
Yeah.
It's scaled, right?
Yeah.
So can you open the KEDA.yaml? I think I did. Did we go through the KEDA.yaml? No, right? Did we go through?
No.
No.
Mm.
Okay. So basically, so it's deploying the deployment and the service. So here the deployment is Redis server. Okay. So we are creating a Redis deployment here and creating a Redis service. You come down. Yeah, Redis worker we are creating. Come down. So we were seeing horizontal pod autoscaler. Check the line number 68. So we were seeing horizontal pod autoscaler, vertical pod autoscaler. Okay. So this is another object called scaled object, which is specifically for KEDA. So based for event-based scaling, you'll have to use this YAML, scaled object YAML, and then API is KEDA. So this is not provided by your Kubernetes. This is provided by your KEDA custom controller. So you will see the CRD called KEDA.sh. Yeah. So you will see this CRD. If you want to explore all the values, go to your CRD and then check which values you need. And then, so check the trigger here. Go down, line number 72. Just highlight it. Yeah. So which target you are referring here? Redis worker. So which is getting scaled? Redis worker is getting scaled. Okay. So from which replica to which replica? Main replica 0 to 5. When there is no load, then it will stop. And then it will go back to 0. When there is a huge load, it will spin up to 5 pods. So 5 consumers or five workers are spinned up. So just stop the load and then after some time it will be scaled down. Just exit. Yeah.
So in that Redis server, which kind of event was happening? So when it will scale?
Go back to the KEDA.
Yeah, so we will trigger a threshold.
Yes. So basically, it's just a simple test. So just a list length. If it's more than 5, that's the threshold in this case. So if it is more than 5, it will scale. So if the job is more than 5, so we have increased the job up to 20 or 30. So when it will scale, if it exceeded 5. Okay.
So list length is threshold.
Sorry. List
And
length
last time.
threshold. So this is specifically for this dummy application, but in real time, queue length will be there. That will be your threshold.
Yes, sure.
So it's based on which trigger type you use. Okay. So now we have used the trigger type as Redis. So you can use trigger type as Prometheus, and then you can call a custom metrics, and then you can scale based on that. So here we are calling Redis, and which address? It's on the local cluster, right? So we are calling the Redis, which we installed now, and then what is the name job, and then we are creating length job, I guess. Yeah. So yeah.
So Lavanya, we can see all the parameters of this as well using kubectl get CRD, right?
Exactly. You are right. Yes. But this scaled object does not have any authentication. Okay. It's simply on the same cluster. It does not impose any authentication. So you need to use authentication if it is from external service. So basically you need to configure username, password, or service account or token, service account token. So whatever based on the destination that you're trying to reach, So you have to have trigger authentication. Can you just hit kubectl get CRD grep -I ignore case -I trigger
Trigger. Okay.
So trigger authentication. This is required. So you can visualize this CRD to check all the parameters and then configure the trigger authentication for that resource. Okay. So this is required along with scaled object if it requires authentication. Is it clear?
Yes.
Yeah.
So lab assignment will be, maybe you can explore more on the KEDA. So just to spin up another, instead of this Redis, just to go back and search and then check some other implementation and then try to do a lab, explore the scaled object much further, like configuring more parameters. So you know how to validate it. So just, just consume more and more parameters so that you understand this KEDA scaling better. Okay, but this is very simple. So people say that KEDA, so those who don't know, this looks big, but it's very, very simple. You just configure it right. Okay. I think, Chetan, you were asking for Cilium brush up, right?
Yes, just an over. I will research by my own, but just a
Let me check. Let me check if I can cover quickly for yeah. I'll open the last week's session notes. But if someone else has questions, just reach me out in WhatsApp. When I get time, I'll respond. Otherwise, yeah, even in the next class, before starting the session, I'll respond and then only I'll start. That is my document. So in the next class, everyone please install Helm CLI because we might use Helm every now and then. So this was our last deep dive. So basically, Cilium comes in networking part. So basically for service networking. So there are two types of comparison. So IP table is one, another one is with Cilium. So we had advantage, we had discussed the advantage of IP tables over Cilium over IP tables. So just revisit the last video. Let me see if I can give a quick overview of Cilium. Yeah. So basically, when you create a cluster, by default it uses IP tables for networking. So in the start of the session, Poluka has described like what is the disadvantage of using IP tables. So why are we using Cilium? There are a lot of tools in the market available for CNIs because Kubernetes out of the box, they don't provide networking solution. So we'll have to use another networking solution. So which is why these tools are getting more and more familiar, or getting more and more advantage or attracted. So this, because this is in need for Kubernetes implementation. So that's why Cilium and Calico, these two are the huge competitors. Calico was there for last 5 years, but Cilium was introduced maybe 3 years back, I guess. But they got a wider market because they use eBPF. eBPF, just go and investigate more what is eBPF. So it is safe way of running your programs. So in simple terms, we can say running a program in eBPF without logging into the kernel, it is more safe, and also we get observability, better observability. So Cilium provides an advanced capability to visualize what is happening in the cluster. So what is incoming and what's outgoing, both ingress and egress traffic is completely monitored, whether the traffic is allowed or the traffic is denied. So end-to-end monitoring is provided by Cilium. So the core components are Cilium operator, which manages the Cilium installation. So every upgrade, so this operator will come into picture, and then it will do all the operations with respect to upgrades or managing number of Cilium agents. If there are new nodes coming, this operator will instruct that this Cilium agent to go and schedule onto that node, because Cilium agent is a daemon. Sorry, it is a daemon set. Yes, it is a daemon set. So every node will have a Cilium agent to perform this networking. So yeah. So Cilium is a container network interface. So it provides the networking solution. So you can think of it provides the solution for service to service communication. So CNI means container network interface. So it's offered by wide variety of tools. One such tool is Cilium. So we are covering Cilium for this bootcamp. Okay. So this is the architecture. So we have Cilium operator, Cilium agent running on every agent, and Cilium is the CNI. So basically, kubelet interacts with your Cilium agent to perform any operations, to perform any executions like ingress, egress, going outside of your cluster. So everything is handled by your Cilium agent. But visualization, complete end-to-end visualization of your traffic. If traffic is allowed or denied, it will be visualized from Hubble UI. Okay. And major advantage is Cilium provides network policy. So I think I given a lab assignment in Cilium just to go back to the previous session and do the lab assignment. So it provides L3 capability, L4 and L7 network policies. So yeah, possible, try that as well. Just go back and then check all the features that are there. What's there in Cilium and what's there in Calico. We did a comparison of all some 3 or 4 tools. So why do we choose what? So what is the major advantage of using Cilium? So we have discussed that in the last class. Just go back to the entire session. I think it's a 3-hour session. Just go through it and you will understand. Yeah.
Sure. So it is a networking tool for Kubernetes. I will
Exactly.
research about it. Thank you.
Yes. I think that's it for today. Yeah, I think it was late. I appreciate every one of you to take your time and join the session. So let's see from next class. Maybe we would start doing on Saturday morning, or let's see how we plan to do. Okay.
Sure.
Yes.
Just put a message on whatever you decide.
Yes, no worries. Then
Thank you.
bye.
Bye.
Okay, good night.
Yeah,
Thank
thanks,
you.
Lavanya. Good night.
Thank you.
Bye.
Thank you. Bye. Bye.